Hey everyone. So this is going to be a quick video talking about Agent S2, which is a computer use agent developed by Similar Research or Similar AI. So I'm just going to quickly go through what this is and then how to get started with it and show you some example code. It's going to be in Python, but it's probably relevant to any language and it would probably look similar. So first of all, Agent S2 is a computer use agent, which means it is essentially like an AI that can control and operate a computer. So you kind of just tell it what to do. Like imagine you just say, open up Excel and enter this data in English, and then it would just kind of figure it out, break it down, and do it autonomously. So that's what it is. And just for reference as well, it's considered to be, like right now, one of the top computer use agents. This is a website called OS World, and you can scroll down here and see, okay, like there's the top ones: OpenAI and ByteDance, which is TikTok. They developed a computer use agent, and then sitting at number 3 is Similar Research. The leaderboards kind of bounce around quite a bit. I think for a while it was actually number 1, but it's floating towards the top. And one of the interesting things about this is it's one of the only ones here that are like fully open source. So we look at OpenAI. This is their computer use agent O3. It's number 1 right now, but it's not open source. So Similar has an open source version, which is super cool. And as well, here is a GitHub repo. This is the actual like original Agent S GitHub repo that they released. It has like almost 6,000 GitHub stars, and you can scroll through this and see some of the technical details and then results on the evaluations, as well as their setup steps as well, how to get started. They have quite a bit of code, or a lot to read through here. I actually went ahead and had created separate code that we can follow through. But if you find it easier, you can also just follow this original code. And one more thing I will show before hopping into the code is they have it linked on here. There's actually an original paper if you're interested in the details of it. There is a paper that you can read here to explain the process and how they designed Agent S2. And I guess one thing I'll also note as well is like Agent S2 itself is not like a model. It's not a foundation model that was trained on data. It is an agent that is using existing LLMs and vision models. So for example, by default, Agent S2 has its own code, but under the hood, it's still using OpenAI and Claude, like OpenAI and Anthropic models. So it's just like an extension of those to make the existing models perform better on computers and give them more tools and memory, etc., to make it perform better and more accurately. Okay, yeah, I think that's some of the original things. I kind of talked through that a lot. But the next thing I'll show is some actual code. So I created this GitHub repo, and I will give the link and the description. You can follow this through. I also created like an article version of this if it's easier to read through. I'll include that in the description as well. But there's this repo here. You can just click on clone, and we'll walk through the instructions. I create some details on the README as well. You will need a couple API keys. You'll need an OpenAI API key and an Anthropic API key. And you will also need, just a normal operating system, Mac, Windows, Linux, and then Python 3.11 installed, or any of the range of 3.7 to 3.11. Okay, so I think I rambled on quite a bit. I'll hop over to an IDE now. And this is actually the same GitHub repo that I have cloned here. You can see here I have an env file. I have an env, and I have both an OpenAI API key and an Anthropic API key, as well as an Orgo API key. You'll probably want all three, and you can just search up like Anthropic API key or just like Anthropic API platform. and then you can go to the console. Same thing with OpenAI. It's really easy. You may have to add a credit card as kind of like a disclaimer on OpenAI and Anthropic, um, but it should cost very little money. You can maybe add $5 or $10 to your account. Okay, and let's quickly walk through the code that I have here to show you what the library looks like. This is running in Python, so it's actually pip installing the GUI agents package, which is given to us by Simular. And I'll open up this as well, so we can see here. Okay, the first steps, we want to clone and go to the folder, and then we can actually follow through this here now. Let's actually get a virtual environment, and then we can run through some of the code, and we can read it and then run it to see what happens. Okay, so I'm gonna actually just creating a virtual environment. This is on Windows, but you can also run a similar command on Mac. And then we'll say this activate. So this is going to activate our Python virtual environment. So when we install packages, it will be contained just within our project instead of our global file system. And then I will pip install requirements. You can see here there's just a few packages: GUI agents, which gives us the code for the agent S2. And then there's Pi Auto GUI, which is actually just a package where you can control a computer programmatically. So you could type into the like code, like call the left click function to actually like left click on your computer from Python scripts. And then a .env to load environment variables, or go if we want like a remote desktop environment, and then pillow, which is like loading images. So we'll run a quick pip install on that, and then there is a .env example. This is just some of the environment variables or settings that you can tweak back and forth when running S2. So by default, there is actually a LLM model. You can see agent model and grounding model. So what this means is the agent model is like an LLM that's sort of like making the decisions. So like given kind of current information, like what should we do next? Kind of like reason through what the next action should be. And the grounding model is actually like the vision-based model that's gonna like read the screen and then determine what the pixel coordinates are to click for executing the action. So it kind of needs to be like a vision-aware model. And then that's going to be given through Anthropic. So in this case, we're using GPT as the LLM and then Claude for vision. Okay. And I will let those pip installs finish up. And one thing to note as well, like I put a thing on Mac here. If you're actually going to run this on your computer and have Agent S2 control your computer, you need to allow the permissions. So you need to give the privacy accessibility options for the terminal application. Because if you run Python, if you run the Python script in the terminal, that's what actually needs to get access. Okay, and yeah, so this script is kind of like ready to go. So once we finish the pip install, we should be able just to give this a run and try a few commands here. And while it's pip installing, I'll just quickly go through some of the code as well. Okay, so there's a lot here, but you can see at the very top, the first thing we're doing is just loading some configuration variables. So you can see here, okay, we're getting a model, which is GPT from OpenAI, as well as the vision model or the grounding model, which we're using Anthropic Claude for. And there's actually, for HNS2, there's an option to have a search engine to basically give some context every time we're about to make a new option, make a new action on the computer. For example, like if we want to copy and paste, this is just a simple example, but we can make it to where every time you're about to do a new action, it would research on the web. Okay, how do I copy and paste on Mac, etc. And then it would load that context to make the next action. So it's kind of like an intermediary RAG, like retrieval augmented generation, if you're familiar with that concept. So this is totally optional. We're actually not going to use it here, but you could enable this and use the Perplexica API, and then that would probably improve the performance. Okay, and then there's also an embeddings model. So this is actually used to store information and sort of like memory. So when we go through all the actions, it will store some of the previous results, so we can reference those later, and sort of like learn how to do certain things, or reuse certain patterns from before. So it's kind of like a basic memory system. And then the other, I think, two other important things, max steps. So when you like ask for a new command, like, hey, open File Explorer, it will try like 10 intermediate steps like as a maximum. So it's like if you say like open Photoshop and do this, it will try like 10 commands, like maybe one left click is one, and then right click, and then type. So that's three. So this would be, yeah, just the max steps per command. I think some of the benchmarks say that you get the best results if you put the max steps to 50. But this is totally up to you. You could start with a low number. And then finally, we'll try locally at first, and then there's also a variable to do remote. So this is actually like locally would be having the agent S2 control your own computer, and then remote would be controlling like a virtual desktop. And the reason why you might want to do this is like if you want to actually build automation pipelines or build like apps to be used in like production. So if you want to like build real things with the computer use, you might not want to give it your own computer and have it access to all your files. And yeah, a few things here. There's an executor here which has a screenshot method, and then an exec. So essentially, the loop is it will take a screenshot and then determine what to do, and then output a code with Pi auto GUI, and then that will be executed. And then the loop continues, then we'll take another screenshot. Okay, I'm not going to go through all this. You can kind of read through some of the code yourself. But you can see here one other important thing. I believe you can search predict. Yeah, so there's one line of code here. This is the library agent.predict, which comes from the GUI agents package, the GUI agents package. And then this library function right here, predict, this is where a lot of like, I guess the magic, or like a lot of the agent code is happening, which was developed by Simular. So this is kind of gonna think and determine what to do. So yeah, I think this is good to go. So let's try to give this a quick run. And we'll try something relatively simple, and then you guys can also play it around with yourself. This is mainly just to get started. Sometimes it can be kind of slow, and you might have to tweak this a little bit to actually get good results. But let's just try to say, like, open up my calculator. Let's see. It might fail. We can see how far it gets, or it might be a bit slow. But this is really just to show you guys. And let's see. Okay, there is missing one thing, which is an environment for OpenAI. Let me check. We do have it. So I think maybe I just need to, let's try to go into the environment again. Let's see here. I have to do a bit of debugging here. Let's try it again and see. Sometimes it just doesn't pick up the environment variables here. All right, so yeah, I actually spent a few minutes trying to figure out what the issue was, and it was actually within my code itself. So this line right here, load.env, I had it at the end here after the imports, but I realized what we actually need to do is do it before the agent S2 import, since that references your OpenAI API key. So that was actually a problem for me. But I fixed the issue, and yeah, let's just try to give this a quick run here. Um, One thing to note as well is that we'll run it on Windows, and I'm on kind of like a high resolution monitor, um, where it's where it doesn't uh, necessarily run the best on a Windows computer, like in high resolution. I think it, like Windows and Mac, it sort of works, but like it might have some issues. Calculator, like let's just try that. But it like runs best on like Linux, on a Linux machine with like around 1024 by 768 resolution. But we can just try to give this a quick run to see maybe like how far we get or like what it can do. Um, you can see like it might not quite get to a result, but you will start to see like it might move things around. Like I'm not touching the mouse right now, and you might just see like it start to click around or move things. So you can see like when we run it, it seems like it's working. It actually like downloads to a file like its knowledge base. It also like stores the embeddings as well. So it can, yeah, so you can start to see it's moving something. I think it decided to minimize my current IDE to see like to explore a little bit, see what it can click. Um, we'll see if it gets there. It might take time. I probably won't wait around. Wait, I probably won't wait around too much for this to finish, but you can start to get the idea of it will click around and move things and kind of explore the desktop, and then it will like reason through and try to solve the problem. So it's so far it's done 4 steps out of 10. We'll see if it's like able to find the search bar. Like I mentioned, its vision performance is like quite like not as good on like a normal personal computer or like a high resolution 16 by 9. I think like 4 by 9 1024 it kind of works the best on. Okay, so it's still trying to like it's struggling with vision a little bit. Oh, it's it's minimizing more things. I'll just go ahead and stop it there. Maybe it will figure it out to the end, but we'll just go ahead and stop it. You guys can kind of play around with it and see if you can get it to do like basic things like opening up apps or like navigating a UI or maybe like filling out a spreadsheet. It takes some messing around with, but it can do some interesting things. And I guess one last thing I'll try to do for this video, and we'll probably end it after that, is like using Orgo, we'll start it on a remote desktop. So this will be on like it'll start a Linux machine like Ubuntu, which is where computer use agents like have the highest performance, and it will have like everything set up to work best with the agent. So it'll be like on the correct resolution. It'll be on 1024, and like have everything to be like compatible with the agents. So one thing we'll do is we'll open up the .env file, and we'll just all we need to do is like you just add in your Orgo API key, and then you just flip use cloud environment to true. That's all we need to do, and then you can also see, yeah, like so from Orgo, we're importing computer. So instead of just using our local machine, what it's going to do is instead create the computer remotely using this code right here. Okay. And so what's going to happen is it's going to create a brand new fresh desktop instance. It's going to be like a clean installed computer. And then we can prompt it to do something. Let's try something out here. Let's just say Python agent S2, and let's just say open up the terminal and type ls. we'll try, instead of just opening up an app, we'll try to make it like slightly more complicated, like a two-step process, since the performance on Linux is a bit better for this agent. So let's just give that a quick run here. And if I open up Orgo, like orgo.ai, you can see, okay, so it ran the code, so you can see like this just popped up out of nowhere. This is a like fresh computer, and you can see, yeah, the agent is starting to like run some commands. You can see it's doing a screenshot to kind of like get the context of the screen and see what it can, and then to see what it can do. So we'll wait a few steps and see if it's able to kind of like navigate the screen visually and open up terminal and then run ls. Okay, so it's starting to do things. We'll see. Yeah, one thing to note as well is that the the Agent S2, it's a bit slow. Like that's one thing. I think it's using like three different models. So it's using the main LLM, the grounding model, which is for vision, and then I think it's also like importing some like local like tesseract or like vision to like read text from the screen as well. Okay, so one thing as well, you can see since the vision is a bit better, like it was able to locate the like main menu on the Linux machine. So let's see. So it went ahead and like opened up. For some reason, it opened up like a file explorer. It probably could have just opened up the application menu and hit terminal, but it's doing it in a kind of weird way, but it is doing some things. We'll see. We'll wait a few more steps here. And one thing as well, like you'll notice is like I'm just doing 10 steps. Um, I would probably just increase that to like 25 or 50. Um, like one thing to know is like I think after a certain amount of steps, um, the agent S2 is able to like self-correct a little bit better and like is able to like if it's having issues getting it like to be like reset and then try a different route. Um, so we'll see here. It is it's struggling a little bit. Okay, so it completed all the steps here. We'll see here. Let's try to we'll before I end the video, I'll try to run it one more time and see. We'll wait a few steps and see what it does. Um, if not, oh well, then you'll just play around with it yourself and see if you can get it to complete some tasks. But we'll see. We'll try it. We'll try it one more time. We can see. Okay. So this time, I realized like it was looking for the terminal icon at the bottom, and it actually clicked on. Okay, yeah, there we go. So it found the application finder, and then it was able to then click the terminal icon. So it was able to this time it was finally able to like locate the terminal. So we'll see if it can complete the last step of just like typing ls. I think is what I asked it to do. Yeah. So you can see, okay, so this time I think it kind of messed up for some reason the first time, but this time it's actually able to like, okay, like three steps: locate the application finder, and then click the terminal icon, and then open it, and then type ls, and then press enter, and now it's kind of like evaluates the result, and then it will, yeah, it's like outputting the contents of the directory. And you can see one interesting thing at the end here is that it actually evaluates itself at the end and sees that, okay, it's outputted the result, and then instead of completing all the steps, it just terminates there and realizes that it successfully completed the task. Um, so yeah, so that was a bit bumpy, but it was actually able to get to a result and work for this task, even though it was a simple task. So if you guys want, you can mess around with it more and try to, maybe modify or improve the code or try to get it to do more and more complicated, and like intricate workflows or tasks. But yeah, I think that will be it. So hopefully that helps, and yeah, hopefully have fun exploring Agent S2, hopefully, and hope you guys build some interesting things with it. And thank you.